Hello, everyone. Welcome to another session of Microsoft Zero to Hero. It's another weekend. We are in July, and that means .NET July is back. Last week, we had Gerald, and he talked about how to use AI inside our MAUI applications. And this week, we want to take a journey back to the basics because what we believe is that knowing the basics and fundamentals is what's going to differentiate people in the AI era from each other. And we are at Microsoft Zero community. You could go to microsofthero.com to follow to follow us on different social medias. This is a community built by the community for the community. So we get together to learn from each other, and we have a simple code of conduct. Be respectful to each other, listen to each other's opinion first. There's always something to learn about. If you go to the calendar, you could see also like the follow-up sessions, like for the upcoming weeks and months. And this week we have Rodney with us, if I could find the, and he will talk about C# abstractions and the lies they tell us about those things. So without further ado, I would like to invite Rodney on the stage with us. Hey, my friend, how are you doing?
Hey Shahab, how you doing? Thank you for having me. Let me start there.
It's a pleasure to have you back here on the stage. Uh, have some words with the audience. I hope they are all good wherever they are in the blue planet and either watching live or later on watching the stream like afterwards.
Yep. And as Shahab pointed out, the topic for today is kind of like getting back to basics. I talked to some developers, not a lot, many used to, but and one of the things that one of the younger developers asked me says, well, nobody talks about code anymore. Everyone talks about AI this and AI that, and no one talks about code fundamentals. And
Yes.
so it's one of those things where getting back to the basics and the foundation that you have is so very important. And when I went to university, I came out, I got a job, and I still didn't actually have these fundamentals because I knew the basics, but I didn't understand the building blocks of software. So this is one of those talks where we kind of get to dig into what we think we know, what we kind of learned along the way, and how we can apply those things for the future.
Yeah, I think that's a very important aspect to take care of, especially at the moment that the AI is generating like super fast all the codes, and we need like to own it. So we need to understand what is garbage and what is valuable code that is an outcome of the process. So stage is yours. Looking forward to it, and let's get it started.
All right, so C# abstractions, the lies they tell us, and the fact that you're likely still doing it wrong. Full disclosure, I still do it wrong every day, but I do my best to make good decisions. If you're not familiar with me, I'm Rodney. I'm a senior software engineer. I've been working in the .NET space for some years now. I'm a former Microsoft MVP. I helped maintain reactive UI at some point. Those are some of my social posts. And all of these opinions are likely mine or ones that I stole from people smarter than me. The agenda for today, what we're going to talk about. We're going to talk about the basics of abstractions. So these talks are always hard because you get people that understand everything you're saying and the people that don't understand anything you're saying. So I always like to kind of level set with where we are. Then we're going to kind of talk about this dependency escape room, right? Like having so many dependencies that you can't think straight. I was looking through a view model at work the other day, and there's like 50, 60 lines of dependencies being injected into one thing. And I'm looking at it and I'm saying, hey, we're probably doing this wrong. We could likely do this better. Then we're going to kind of talk about some of the guidelines of what abstraction really is. We're going to talk about what modern C# techniques are available. And then I'm going to give you a concrete example, the build system example. And we're going to kind of go from there. So this is my obligatory disclaimer. Do not go to work Monday morning next week, whenever you go to work, and tell your architect, hey, we got to go do all this stuff that Rodney guy talked about because it was great. Or, hey, this Rodney guy talked about it and we should try all these things. Don't do that. Instead, interact with me, interact with other people, like learn it on your own time. Try and understand the lessons that are really there, because this is some pretty heavy stuff, and some of it's high level, some of it's low level. But you have to do what's right for you and not get caught up in these buzzwords, and you can't go out there pitching things that you can't really stand behind.
And remember, guys, learning by doing doesn't mean to do it in production. Learn it first by doing it multiple times on your own time, and then apply it in your project.
Yeah, I don't like to do anything in production. As a matter of fact, I've told people I'm a developer. I don't want to even have keys to production. Don't show me where production is. I stop at QA. I don't go any further. So yeah, so do this on your own time. Like you said, don't test in production. Test in a sandbox.
Yeah. Hello, Stefan.
Hello. Stefan, my friend. So why should we abstract? And this is where we're going to start telling all the lies, right? So I've heard intelligent developers get on stages and say we should abstract because of testability, or because it's for maintenance, or because clean architecture or onion architecture, or whatever flavor of architecture we're using this week. I think the most latest one's like microservices. Have they done something new since then? Like, so because someone else said to do it. Oh, well, the senior said it and I'm the junior, so I got to do what the senior says. No. So I'll go ahead and tell you, yes, you have to do what the senior says to a degree, but you should learn from the senior and learn when to push the senior to get more information out of them. Don't just do it because they said so. Right. Yeah. So what are abstractions, right? So we can't talk about what it is until we talk about like the definition, right? So like, this is one of the things that I brought up actually in a technical meeting the other day. I said, who actually knows what this is? And, one guy raises their hand. So the fundamental theorem of software engineering says that we can solve any problem by introducing a layer of indirection, right? So what is a layer of indirection? A layer of indirection is an abstraction, right? We can implement some abstraction and we can solve the problem, except for too many levels of indirection, right? So this kind of gets concept where you don't want to be not enough levels of indirection, not too many levels of indirection. You want to have just the right amount of indirection, right? And that kind of brings it home. Like, this is the only reason why we should actually abstract things, is when we're trying to solve problems. We shouldn't abstract things because it's the way we do things on this project, or it's the way I've been doing it my whole career. No, we should only do it when we're trying to solve a very real problem, right? Because abusing it has a cost. Not adhering to it has a cost, right? Like you can create these extremely tightly coupled systems. You can create systems that are not testable at all. And every single time you push to production, you're hiding on your desk because you're afraid the entire production system is going to fall down. I mean, and I'm laughing because I've lived through this, right? Like I lived through an engagement where I worked on an SAP system, and we were, every time we would push to SAP, we would literally cross our fingers and hope that it wouldn't break the entire world, because at the time there was no testability built into SAP, right? So these things are not just buzzwords or things that architects decree from on high. These are things that can actually save your weekend, right? If you understand them correctly.
I think one thing that I really like is like this abuse is costly. I think we need to learn like that the code is not an asset to us; it's a debt, right?
Yes.
And the more we add there, so we want to do a lot more work with less code. Like, this is like kind of the goal, right? And adding layers of abstractions just without considering what benefits it brings, like, to me, seems like just
no, you're gonna. I mean, unless you have limitless money, you're gonna hit a wall.
Yeah.
There's the joke is I can solve any problem with enough time and money, but there's never enough time, and the money always dries out. So, yeah, good point out. So abstractions, right? They hide complexity behind stable boundary. Oh yeah, SAP. Yeah, SAP. I love SAP for what it was when I worked on it. It's gotten better. I haven't worked on it in years, but it was a fun one. They enable extensibility, right? Because you can make composed elements. You can share behaviors across objects. They improve testability, right? Like, we can mock abstractions. So that way we don't have to test an entire module together. We can break down the testing of the module into smaller chunks, and then we can decouple things. And this is like, everyone talks about decoupling, and I see this slide all the time where people like high level policy, low level, cohesion, blah blah. Okay, so look, this is what it comes down to. High level policy is the contract, right? We sit with the integration team and we say, hey, you're going to give us this data. We're going to expect this data. This is the JSON schema. Those things are high level policy contracts, things that one piece of a system, because you may think that if you work on a mobile application, your job stops at the mobile application. No. If the data doesn't make it to the backend system, your application is worthless, right? So the contracts that we have between various parts of the system, even though we don't look at the system holistically, right? And then the low level implementations, right? Like how I actually go and implement that contract. Am I returning IEnumerable with yield return everywhere, or am I properly or not properly? Or am I calling the enumerators? Like how are we actually doing the work behind the contract? Right? That's the concept of decoupling, understanding how to make that seam work for everybody involved. So interfaces, right? Like that's the main C# abstraction that we have. This is probably my favorite C# abstraction because it's very, very thin, right? I can take a interface and put it on a third-party library and abstract it from, or at least make it testable to some degree, as long as there's no IO, right? Like if it's a database, okay, yeah, you got me. But you can make thin layers with interfaces. And up until recently, somebody in the chat is going to tell me, because it's this time I've got it right. In C# 8, we added default interface methods or implementations, and that gave us some level of definition to interfaces. But up until then, it was just a contract. It just said, like, this is the expectation. There was no actual implementation. And it represents this can/do relationship, right? It's kind of, what do I have access to and what can I actually do with that access? That's kind of what these interfaces allow you to define. And you want to use them when you have capabilities or methods that exist across class boundaries, right? So let's say that we are being good stewards and we have a mediator implementation, right? And in one domain, we have a subsystem that needs to get called, and in another business domain, we have the same subsystem that needs to get called, but we don't want to duplicate that logic in domain A and domain B's handlers. So we can abstract that out to a service or a manager or some abstraction that allows us to share that behavior across that boundary without coupling the boundary to a low-level implementation. I think that's the key, right? Like those are the things that we don't pay attention to when we start creating these interfaces or these abstractions. We just go all the way down the, oh, I got to do this, I got to do that. No. Take a step back and think about the requirements. And this is where I'm gonna put on my business hat for a second. Think about the requirements. We're developers. We don't write code for the fun of writing code, unless you're weird people who write code on the weekends and at nights for fun. And they do it. It happens. But we write code to requirements, right? Like we get a set of requirements and we have to satisfy those requirements in order for that code to pass some levels of gates. So we should be solving problems that satisfy those requirements with our interfaces. Abstract classes, right? So this is one that I don't see people using often enough, and I generally see it being abused. But an abstract class represents a relationship, right? This thing is a entity on this type hierarchy, right? So it can share the behaviors, it can share constructor parameters, fields. You can create protected backing properties, right, to share behaviors and dependencies across the inheritance hierarchy. So that's kind of where abstract classes can get you a little bit further. I don't think of or relationship with interfaces. I think of an and relationship with interfaces. You can use interfaces and abstract classes, not an or, right? Because an interface can define the contract, but the abstract class allows you to share reusable typed concerns or behaviors across that are down that inheritance hierarchy. And that's a very interesting point.
So we have a comment. So when building a shared library, I became to dread interfaces, hard to extend without breaking, when default interface members cannot be used. Well,
Yes.
.NET Standard 2 style, yeah.
Yeah. So that's and we're going to get into that in a minute, but that's exactly it, right? Like one of the problems with interfaces as we have used them traditionally is we put too much stuff on them, or we don't pay attention to the boundaries. We don't pay attention to the problem that we're solving and the requirements that are in front of us. And we stick things in the wrong place, or we couple things to the wrong interface. And then it's part of that contract. So when you're building a third-party library or something that a third-party entity is going to consume, even if that's internal to your enterprise or your organization, if you break the contract, you create what's a breaking change. And now everybody that consumes it has to deal with the fact that you broke it. So if you aren't using these techniques correctly, you can create more breaking changes than you actually have to. And that's a very, very interesting concept that I didn't pay attention to in my younger years. That bit me very, very hard. And there's actually an example of that going to be coming up here shortly. So yeah, interfaces are one of those things that you have to be careful about, right? It's the contract. Don't break the contract. Abstract classes are shared behaviors. Don't break the shared behaviors, because if so, and this is where inheritance can become a problem, right? You have 15 levels of inheritance, and somewhere in the middle, you make a change and you break everything down the last 7 layers. Well, now you've got to spend the next 3 hours figuring out how changing this int to a uint breaks your entire domain, right? So
Yep.
Understanding that how those relationships between code works, that's that coupling and cohesion concept, which we're going to talk about in a little bit. So we get into the lies. Yeah. And I'll full disclosure, I have been told these lies. I have used these lies to justify doing things. I am not above any mistake, right? Like I've made it. I've made the mistakes. I've been the guy. I've broken the thing, and I've spent all weekend trying to fix it. Right? It happens. So interfaces. This gets into kind of what Stefan was just talking about, right? Interfaces are class contracts. They're contracts about how things have to behave, right? We should create an interface that defines the entire class. No, we probably shouldn't. We should create an interface that defines what a portion of the subsystem requires in order to do its job, right? Interfaces are for tests. Oh, well, you can use abstract classes for tests, right? You can use anything that the language, in our case, abstraction, and use that and for or a test fake. The Yagni principle doesn't apply to interfaces. I might need this in the future, right? So I'm going to put it on the interface. Like the repository pattern is a great example, right? Oh, I'm just going to create these CRUD operations on everything because it's better that way. I don't have a single piece of my subsystem that actually ever deletes this thing, but it's got a delete operation. And as a result, some developer can walk their way into it, accidentally use it, and break our entire application.
But you could have a generic repository that implements the CRUD ones and then inherit from that. So you don't have to implement it multiple times, right?
Right. That is a way to do it. But thinking about it from the interface segregation perspective, right? Now I've given you access to things that you shouldn't have access to. Like this is a read-only. Let's consider a concept of read-only data that comes from our client, right? The data doesn't change once it hits our device. So why would I give you the ability to delete it?
True.
Now you're deleting what we would consider static data that we need in order to generate the business model. Now, yes, we should catch that on a code review. Yes, the developer should know better, but let's be honest, we're engineers. We live in really complex code bases. It's not always that easy to know, should I do this or should I do that? Half the time, the requirements are unclear. So I don't know whether or not I'm doing it right. Like, these are the things that we should be trying to guard ourselves against. Again, I told you, I don't like access to production. So I don't want to be the guy that broke production and has to wake up at 3 o'clock in the morning on a Sunday because payroll's not running. A SAP joke. Yeah, that actually happened. So you know, it's those moments that we are trying to guard ourselves from by using these abstractions, not for the lies that they told us, right? Like, oh, one implementation is still polymorphism, right? So like, I'm going to put this interface on here because I might need it in the future and I'm going to need polymorphism. So I want to use it and inject the interface. No, sir, you have one call site in the entire code base that's going to use it. Use the concretion. And when we need to abstract it, we can. It's very simple in a lot of the modern IDEs. We were talking about this earlier, right? Back in the day, back in the before times, you used to have to write this in Notepad, compile it from the command line, right? But now you can Alt enter and refactor and create an interface in seconds from the class. So your reasonings change, right? Like, we don't need to do things the way we did things in the antiquated past, right? And then interfaces should represent the whole object, full stop. I've done this, right? With DTOs, I used to do this. Oh, I want the contract to be defined on the interface of the DTO, and then the concretion will just be a POCO. So much extra code for no value, for literally no value, because I'm not testing it. I'm not doing anything with that interface. I'm literally just creating an interface for reasons. And this is one of the reasons why I used to do that, right? I came from the C++ world, right? Where you had to define a header file for every class, right? So in my mind, that was kind of the way you did it. And when I got to C#, I just kind of carried it over because it felt comfortable. They said, oh, interface is like the header file. So in my mind, that told me I've got to put an interface for everything. No, don't do that, right? Because that's not solving a problem. You're just creating indirection. And what is in, and this is, and Shahab said it earlier, and this is the joke, right? The indirection is the maintenance, is the I forget the exact word you use, but it is the maintenance burden that we're creating, right? It's the slop. It's all the extra code that we don't actually need that just sits there and keeps us from being agile and moving quickly, right? Yep. Why? Because, oh, well, somebody put this thing on this interface and I've got to abstract this. It's going to take me, I got to rename all these files, and we're just adding technical debt. We're adding technical debt with every line of code that we put in a system that doesn't need to be there. Every interface that gets injected that gives a subsystem too much access is a maintenance burden. And we don't appreciate it because we don't pay attention to technical debt, right? Like, we're just slinging code, right? These days we're vibe coding. So we're just throwing the code at the wall. It's going to stick. It'll be okay. No, let me tell you, it will not be okay. Somebody will find it. Somebody will abuse it, and it will become a problem. And you can't blame that junior who didn't know any better. You got to blame yourself. You're the one that made the decision to do this, right? Not them. You can't be mad when they say, oh, I have access to a delete method. Let me use it. Instead, you should have written your code so they could never get access to that delete method if they weren't supposed to.
Oh, yes.
Yeah. So the Yagni principle doesn't apply to interfaces. And this is a funny one. This slide is purposely meant to be small, right? Because we look at how much stuff is on this, right? Like, this is the everything service. It can do login, it can grab users, it can save files, it can log. Why do I need more than one interface? I can use one interface and define my entire system. Oh man. I've heard intelligent people make these arguments. And it's like, it's not wrong, but it lacks that understanding of the maintenance burden that we are creating, right? Understanding solid principles, right? Like, and again, solid principles are buzzwords, right? Like, we use them as interview fillers. We don't truly understand how to use them and the power that they give us. And that's part of the reason why we're talking about this today, right? So again, that one line implementation means polymorphism, right? I have that thing and I need to create an interface for that thing, even though it's just a marker. It defines no behaviors. It has nothing, but I gotta create an interface, right? Because that's the way we do things. No. Be the change. break the cycle.
Yeah.
Do yourself a favor. This is not going to get you anywhere.
Break the wheel.
There you go. And then, like, the interface has to represent the whole object, right? Like, again, that DTO concept. And I have evolved since this point. I still use interfaces to define DTOs, but I don't do it this way anymore, right? Because now I've gotten into complex things where, oh, like we said, breaking changes in public APIs. Oh, well, I own an API, or I represent the owner of an API that produces data that can be consumed all across the internet, right? I have clients, maybe it's a free service, maybe it's a paid service, and every breaking change is now more debt they have to do. So now my bad decisions have an exponential effect to all of my consumers, right? That's what Stefan was talking about when he's saying those interfaces and those third-party libraries, right? Like this causes a cascading effect when you create these breaking changes. So we've got to find ways, better ways to define the seams that we are trying to produce. So then we get into the concept of like the traditional approach of doing things, in like the composition approach is kind of what I'm calling it, right? So where we have this user service and it gives us access to everything that we can do on a user, which, yeah, that's great. Or we can break down the interfaces, which again are just the abstractions. It's just how the various pieces of the subsystem know how to access things. It's the contract, not the implementation, right? We can do this and segregate the interfaces and still put all of these on the same implementation, right? So we can still have a user service that defines get user, save, delete, notify, right? We can still put all that on the same concretion, but we should break up the interfaces so that the reporting subsystem doesn't have access to delete things or doesn't have access to save things. The reporting system should only ever get data. Maybe it should notify, but it should never be able to mutate data. But if you put all the things on the user service, the only thing stopping a developer from doing it is that developer knowing better, versus your system being architected in a way that completely prevents them from falling into that trap, that foot gun moment, right? Where you are basically just handing them a loaded foot gun and expecting them not to blow off their toes. Shame on you. Do better. And we get into the fun, right? Composition versus inheritance, right? This is about relationships. So we talk about and I think it was Bob Martin. Somebody was doing shorts on the internet and had a very good short about composition versus inheritance, and the fact that the entire argument relationships of code in and sharing of behavior across boundaries. That's really all composition and inheritance are trying to solve, right? I have a customer ID. I have a purchase order. I am a purchase order, right? That defines what I am. It defines what I can do, right? And we don't look at our code in that way, right? We just write code to solve the problem and we move on. But we should look at this code as a living, breathing entity with purpose and passion. With the new AI revolution, they tell you, oh, well, if you give AI purpose, it does better, right? Well, guess what? It was always that way. You just weren't taking advantage of it. Describing the code, describing the complexity of your system in a way that is composable, and you can use the inheritance structure to define what things are and what they have access to, so that we can share behaviors and properties and concerns across boundaries in a cohesive way. Very, very important.
When we talk boundaries, do we also like to talk about like technical boundaries, like if you're using like a vertical slice architecture or a hexagonal architecture? Is it the same boundaries that we are talking as well?
So it's a great question, Shahab. The reason why I explicitly just use the term boundaries is because it's very much that go where you find them wherever you find them, right? Again, the boundary could be between the user interface on a mobile app and the view model on a mobile app, or the boundary could be between the user interface and the back end of the mobile app, the database, or it could be between the user interface and the data stream that it's consuming from, right? Because we're using an observable pattern, right? It could be anything. It could be the boundary between one system and another. It could be boundaries inside my own system. The boundaries will present themselves when the problems present themselves and we find the need to add the layer of indirection. So the boundaries exist where the need to add indirection exists. Does that answer your question?
Yeah, absolutely. I have another question to the previous slide, maybe, because there we are defining like we are very explicit about like what the interface can do, right? So we have I can get users and I can save users, and one way that I could think of is like usually in like business applications we have tons of scenarios that we need like an interface or an object that gives us data, we operate on that data, and then we want to save it, right?
Mhm.
And then it's very easy for the users or for the developers, like I'm not sure if I should call it like the trap, to have like an interface that has both of these things like
Mhm.
exposed, and then it becomes overall like in every places we just have
Yes.
like the same interface that is doing both or multiple activities just because it's easier to do so.
Yeah. So
What is the take, or what? How could we like think about these traps?
yeah. So again, we talked about this earlier, right? We're in the before times where before they had dependency inversion containers as a first class citizen in .NET, we used to have to new up objects and do singleton pattern
Yeah.
and right. So it's kind of the same thing. So okay, so this is the point, right? The interface is a contract that lets you add behavior and functionality to various portions of a subsystem, right?
Yeah.
What that subsystem needs is dependent upon its purpose and role. So the interfaces that it needs does not equate to the concretions that it requires, if that makes sense. So
Okay.
I can put all of these interfaces with modern dependency inversion magic. I can put all of these interfaces on a single concretion, inject them by their individual interface, and still get the same concretion under the hood at the dependency resolution time. So I'm not breaking up the concretion into multiple different classes. All I'm doing is allowing my subsystem minute pieces of functionality that they may require in isolation. Now, the question that you're not asking is, how do you get there? And that is the hard part, right? Like, can you start there? Oh, I gotta, again, back to the disclaimer. Monday morning when I get to work, oh, I need to separate all these things into micro ties, right? Microservice, the interface. No, don't do that, right? We're going to get to it. We haven't hit that slide yet, but it's single responsibility, right?
Yeah.
It's not that it has to be a single method per interface, right? It doesn't have to be a single microservice per server, right? But it has to be the smallest set of cohesive functionality that a subsystem needs to do its job. Again, we're talking about code doing a job. And if we think about it in that terms, we start to understand that the way we section off our subsystems is all based upon what responsibilities and what behaviors they need to perform.
Yeah.
Does that answer your questions?
Yeah, sure. And also, like, feel free, like, if there's a questions that you have the answer, like, in a couple of slides after, then just postpone the answer, like, to there. Don't want to interrupt your presentation.
Oh, you know what? I'm very organic with it. I prefer to, even if we get to the slide, I'll just brush over it because the conversation, in my opinion, is more important than me. Like, I'm not a professor, right? No one's here to sit here and listen to Rodney dictate, course 301. We're here to learn from each other. This is a community, right? Like, I learn this stuff. Hey, Rodney, there's a pattern called mediator that solves your problem. And I'm like, wait, what? No, that doesn't solve. Oh, wait, it solves my problem, right? That's what we need. So conversation is bring it on. And if you have, if you want to type in chat and have questions and I need to go back to a slide, forward to a slide, let's do it. So we talked about composition versus inheritance. Yeah. Okay. So then, the domain composition approach, right? It's about what I have access to, right? Because again, this is about various pieces of the subsystem shouldn't have access to everything. And then what I can do with what I have access to. So I have and I can. And now let's talk about state management. Let's talk about that in the context of state management, right? I have access to this state, i.e., I can read this state, and then I can do something with this state. I can mutate this state, right? So now if we get into like the Redux concept, we're talking about reduction, right? We're talking about what I can read and what I can actually reduce. So understanding these things and looking at the code as a living, breathing organism is something that has a job to do, a function, a purpose. We start to look at the code in ways that, hey, maybe the code itself isn't healthy. Maybe we're getting a whole bunch of random 401s at 3 o'clock in the morning because the code isn't healthy and somebody wrote it incorrectly or didn't segregate something. The code has health. The code has to be maintained. The code has longevity. And we, the engineers, are responsible for it. So we've got to understand these things, like, what it has, what it can do. The dreaded solid slide. This is where we get into the goodies of the buzzwords. Yeah. So solid, specifically for composition, I'm only going to talk about 3 portions of solid because again, this is about only the parts you need. Oh, there we go. I'm clicking buttons completely and totally incorrectly. There we go. So solid for composition, right? So SRP, single responsibility, right? Again, single interface, single behavior. We talked about this. I don't necessarily want to microtize my interface to have one method per interface, but like, let's say I have an interface that has a customer, and then I have an interface that can operate on customers. Well, then it makes sense that the thing that can operate on customers would have to have a customer to operate on, right? So if you want to couple those 2 things together on an interface, there's no problem with that, because as we're going to see in a little bit, there's techniques that allow us to implement multiple interfaces on a concretion in C#. Liskov substitution principle, right? So injecting that behavior cleanly, right? Like this, like putting, like not leaking the details all throughout the subsystem, right? We shouldn't be giving access, and parts should act based upon their contracts, right? We shouldn't be surprised when we call I can save and it accidentally notifies, right? Like that's not what the contract I called. It shouldn't do that. Well, your implementation of the contract can do whatever it wants, but if it doesn't adhere to the contract, it's going to get weird in the middle.
Mm-hmm.
And then interface segregation. This is like the secret sauce that I feel like a lot of people don't understand, and I didn't understand for years until C#8 and default interface implementations came around, right? Segregating things into specific roles so that you can describe your domain in a cohesive manner. How do I explain this? If the domain or the business problem that we're talking about is brushing teeth, I mean, yes, water is involved in it, but we should be coupled directly to cases of water in a clean pot from the faucet. And some concept of water is brushing teeth, but understand. So if we can create a clean interface and segregate it such that the concepts that go with bottled water versus the general concept of potable water don't bleed into the same abstractions. Mm-hmm. That's kind of really what we're talking about here when we talk about interface segregation. And together, these 3 pieces of solid will fuel this concept of domain composition, right? Like we can create composable domain objects, or a composable domain, or a composable application if you're not using domain-driven design, because you don't have to. We can create composable objects by understanding and leveraging these tools, right? Because again, solid is not buzzwords, it's tools that we use to build software.
But whether we're using domain-driven design or not, here in this context, domain means something that is representing a model, like in the code of the real world that we have, whatever approach we're using.
Yeah, so domain modeling is the concept of modeling real world concerns, right? Taking out the trash, going to get a haircut, right? Like understanding the mental model of what that is. And that's also very important in this AI world as we get into specification driven development, right? If you don't understand the domain and how it's composed and how it behaves, how can you explain to AI how to build it? And how can you trust that what it gives you is correct? Because you don't know. These things matter. Yeah, good. As an experiment, I've done it. And let me tell you, AI comes up with some interesting answers. It's fantastic. So the coupling and cohesion. Yeah, I hear this all the time. People talk about you want to reduce coupling and high levels of cohesion and low levels of coupling. Yeah, but how do we get there, right? So and then we use and I explicitly have the eclectic terms on this slide so that we can talk about them, because at this point they make me laugh, right? Like I read that and like the degree of interdependence between software modules. I don't know about you, but like I'm a regular human that doesn't speak like nerd all the time. So that's a lot of words that don't really help me apply this principle. Really, all we're saying is that if the billing system and the invoicing system both need to access the database, that maybe those two things are both dependent on the database. So should we find a way to reduce their dependency on that scene, right? Should we create an abstraction? Should we create two separate databases in the microservice world, right? Like, what is the correct layer of indirection to solve that concern, right? And then cohesion is, go ahead. Oh, I thought you were going to say something. So, and then cohesion is the degree to which elements in a module belong together, right? So back to my teeth brushing example, you know, for brushing teeth, the module of brushing teeth, you need a toothbrush, you need toothpaste, you need water, you need something to empty your mouth. Like, that's the things that come together that make that module, right? So again, we don't want to know exactly what the interdependence of what type of water or a sink versus having indoor plumbing versus not having indoor plumbing, because you still have to go brush your teeth if you camp. You still got to go brush your teeth if you don't have indoor plumbing. That brushing teeth doesn't change, but the aspects of the module, the contracts that we use, the way they are defined doesn't change, but the implementation details of those contracts change. And then again, like I said, it's that relationship. So understanding that high cohesion, that the things go together, right? The domain we're trying to solve is the cohesion. So don't bring things in that domain from outside that domain and expect there not to be a penalty.
Maybe you refer to that like later or something, but is it the concept of like things that change together belongs together kind of concept like plays here, and like controlling like how these are interacting with them, right? Like have to have control over them and not the other way.
Okay. Yep. No, that's spot on. Yep. That is a way that I've heard it said before. And I don't use that term, but I've heard it used that way. And that's exactly it. The things that change together, right? Again, back to the single responsibility. If these things belong together, they belong together. Why would we take them apart? But if they don't belong together, why would we stick them together?
Yeah.
Yeah. And then there's the representation of this composition in modern C# is different than it was when I started C#, and it's gotten worlds better, right? So we were making the joke, Shahab and I beforehand, where you get all these C# language features, and they give you the specification, and they tell you to go off and use it, and then that's it, and you don't really know how to use it, right? So one of the ways that this is represented in modern C# is default interface methods or implementations. Now in C#, I can define an interface, a contract, but I can also give it behaviors, which gets us closer to this multiple inheritance concern that C# does not have. I have lived in other languages briefly here and there, and other languages have a concept of multiple inheritance. A class can inherit from multiple classes. In C#, the only way to do that is through interfaces. A class can extend multiple interfaces, but doing that, you don't get to share those behaviors. So with default interface methods, now we can share those behaviors with that contract. So one that I use quite frequently, right? I have a iJSON serialization deal, right? And all it has is two methods, serialize and deserialize. Do I need in the modern C# world, do I need a concretion for that? No, I don't. I create my iJSON thing. I give it a deserialize method, a serialize method. I literally just call out to system.text.json right there on the interface, because I'm not going to test it, because if I've got to test system.text.json, Microsoft dropped the ball, not me. So I expect that scene to work, right? So I just create the interface. And now, instead of having to create an interface and a JSON class and a constructor and all of these things, everything's just defined on my interface and I'm done. And then I wire up my interface and my DI and I'm done. So yes, it now gives us some shortcuts to where we don't have to create as much technical debt to solve problems. Another way that we've gotten from the C# language team is extension methods, and by proxy we've gotten now actual class level extensions, or that we can do, where we can do mixin style extensions. So those things added an immense amount of value, because the biggest problem used to be, back to Stefan's third-party library example. Stefan owns a library. I consume that library, and he owns the contract, and I can't mutate the contract because he owns it. Well, with extension methods and class extensions, I can now extend any type and provide it my own behaviors without modifying. Again, so I'm going to use another solid word that I wasn't supposed to use, but open close principle. I don't have to modify the contract. I can extend the contract using these extension methods. And then I told you that we can define the same thing on multiple interfaces, and this is where that interface overlap comes in. And this is a very important thing. I can define the same property, the same method on multiple interfaces, and extend them on the same concretion, and have two separate behaviors that implement those two very different contracts. That is a very real possibility in the new world, which is something that I didn't use before. So default interface methods, right? C#8. The value is that the interface can evolve without breaking changes. So this was the very interesting part that Stefan was pointing out earlier. Is like, now we can change the API surface without breaking changes, because we have the ability to do this. Because it's still an interface, and because you can still override it. You can still use the override keyword, and you can do whatever you want with the implementation. You don't have to take the default, but it gives the ability to share that behavior in a way that C# couldn't do before, because you can only share behaviors previously with abstract classes. And again, you can't implement multiple abstract classes. So it gives us the ability to do that. But there's, as with everything, I'll tell you, there are always trade-offs, right? Don't think that there is a silver bullet that's going to, destroy that horrible werewolf for you. It doesn't work that way. You just have to, there's problems with this, right? And the diamond problem, right? There's ambiguity. There's an issue where the functionality is only accessible by the interface itself, which means if I cast it to the concretion and I try to use the default interface method that's on the interface, I can't access it. Right? I can't actually access it from the concretion typed as the concretion. I can only access it from the interface that it's created on. So it does have that drawback, but as long as you understand what that drawback is, you can use this and wield this with power, right? And that's the important part. Yep, and like I said, there's more fine print to this. You can't share state. You can't share instance state. I found that out the hard way when I was playing with it. I was like, oh yeah, I can. Now I've got the ability to do multiple inheritance. Nope, you don't. You can use the property, but you can't share private fields or other things of that nature. If the property is defined on the interface, you can read the value expecting it to be there, but you cannot guarantee the value will be there. And that's a very real problem that I ran into personally. So there's also the explicit implementation that you can use for interfaces. And this is where I was saying you can have two interfaces that define the same thing, and the implementations of those contracts can be vastly different. You can use a technique called explicit interface implementation and define the contract on the concretion in the way that you want to, and share only the parts you want across contracts that have similar API surfaces. And then the discovery problem, because the implementation is in the interface, sometimes for some people that can be harder to understand. This is something that you can use documentation, as long as you document what you're doing. I use XML documentation for stuff like this, because once you tell the developer they can hover over the interface implementation and just read the remarks and understand what the design decision was, it gives them power back in those scenarios. And then we've got the extension methods, right? Like, so it gives us that compositional foundation, right? Like we can do fluent API definitions and builder patterns and all sorts of things. Like I said, we can extend third-party libraries and do custom things in our code against those libraries. But again, we talked about earlier, those are very key things that we have to do purposely, because what I find is that we do that, we forget about it, and then we go upgrade that third-party library. Third-party library has breaking change. Breaking change doesn't match with the change that we made against the extension, and now Rodney's got to sit there for an extra 30 minutes to an hour figuring out how to get around this breaking change because we extended the behavior of something we didn't own. So not to say you shouldn't extend behaviors for things you don't own. I'm just telling you that this is one of those moments where you could cause yourself some duress. So be careful when you do it. And again, that interface overlap, right? So I am very much the type where in the past, oh, yep, here it is. The next slide is gonna talk about it. In the past, I used to define things on one interface, and then I would share that interface, and everything would extend that interface. And I locked myself into this really gross inheritance hierarchy just so that I could reuse a property and its type, or a method and its signature. Don't do that. If you have a very real and different thing, again, things that change together, if you have a very real and different thing that doesn't need to change with this other thing, it's okay to define the same method on two different interfaces. Like people will tell you, oh, that's gross. Oh, you shouldn't do that. Oh, why? They'll call out on a code review. Oh, you've already got this defined here. Don't do it in both places. No. Define it in both places. And if you don't need it later, they can merge together. But while you're expanding an API surface, define it in a separate interface. You'll thank me later. I promise you will. So this is where we get into this very concrete example, right? This is how I used to, this is how I am now defining my DTOs by contract, right? Because a DTO in version 1 may only have a name, but in version 2, we want to give it a display name. If I, and someone asked me exactly this question, which is why this slide exists. They said, Rodney, well, why doesn't thing 1 V1, why doesn't thing V2 just extend thing V1 and then you don't need it? Well, V1 is locked and it's no longer going to change. And V2 doesn't, again, back to Shahab's point, V2 doesn't change when V1 changes. So why would we define them and couple them together? See, that's what this is about. We're learning that now we can use this approach, define the interface, define what is going to change on this V2 contract. And then if, I didn't do it here, but if V1 and V2 truly needed vastly different implementations, we could use a default interface implementation and say thing V1.name, thing V2.name, and we could define different behaviors for the different versions of this contract, and no one is accidentally coupled. No one is going to come calling and say, hey, Rodney, you're creating a breaking change. No, I'm not. These things won't break because they are defined with the things that own them, right? The behaviors that define the things. That's the important part here. So using interface segregation in this way is something that I didn't do when I first started, but it has given me immense amounts of lift, because now when I need to go deprecate thing V2, I don't have a whole bunch of changes to make to thing. I literally just delete the interface, delete the extension, and everything continues to work. Where in the previous world, I would have had to, now I got to move name to V2 and I got to modify things instead of don't get into it. Just fun one.
Just also to clarify here, when we're talking of like API contracts, we're talking about the contracts between different boundaries, like as a public interface, right? Yes. So I assume the downstream is using I think V1 or I think V2 and doesn't have any idea about the thing itself behind the scene.
No,
am
I right? Yeah, you are 100% correct, because we depend on abstractions, right? We don't depend on concretions because we're using solid, right? So that's exactly it. So now you could define an entire subsystem around V1, and when V2 comes along, if you're notified of a serious breaking change, you don't have to go modify, again, open close principle. You don't have to go modify the stuff around V1. You can just go extend and fix only what you need for thing V2. And that's exactly it. Because we are using abstractions, and because we are using indirection, and we're not depending upon concretions, we have this ability. But again, we talked earlier about default interface implementations. If we injected thing directly, we would lose access to iThing v2's default interface implementation, right? We wouldn't have access to it because we're looking at the concretion, not the abstraction that defines the contract. Very good question. Awesome. So another place where you can see this is people are starting to adopt this query object pattern. I'm not sure if you heard about this, but it's basically the repository pattern the way it probably should have been done from the beginning, where we segregate the interface, we inject the pieces that we need, and we can keep the same concretion. We can keep a thing repository behind the scenes into sub doing a job. It's model your software in a way that doesn't model the real world. But we do it because of all the lies that we've been told, all of the reasoning that we have. Oh, because of clean architecture. Oh, because of this. Oh, because of that. And I'm not knocking any of these things. I'm not saying that you shouldn't use these architectural patterns. I'm simply pointing out that you should take better care of your system and pay attention to the health of your system, because these things are actually health indicators of the maintenance burden that you're putting on your developers, on your business, on the money that comes in, right? Like, you are the one creating this problem, not the business asking you to satisfy the requirements. The way you satisfy them is what is. So we don't want to create these God objects with API surfaces that have access to the kitchen sink, right? We don't want one interface to rule them all. We want to break those things down into cohesive chunks, right? And here's a concrete example of exactly what I'm talking about, right? So again, I'm explicitly calling this a context because repositories are like weird to me these days. But you see here, I'm explicitly using default interface implementations, right? I'm explicitly, again, I'm using these interfaces that can be injected into the system, into various portions of the subsystem, and can get the same session context concretion, but they will only ever have access to what they need and nothing more. Now, here's the question that everyone asks me, and I think you asked it earlier, right? Okay, well, I need to get data and then save data. Okay, well, inject the I find and the I save. It's still the same concretion. If you do your dependency magic correctly, you're not going to create multiple concretions for the implementation or for the interface, right? For the abstraction, you're only going to create one. So you're going to inject the same concretion into your subsystem. So why does your subsystem care how the thing gets there? It should only care about what it can do with the things that it needs to do its job. And that's where we fall down as the engineers.
So if I want to extend on that, like if I am at the API level or like at the kind of application layer, and I inject I find by ID and I save entity, whatever the interface name is, right?
Right.
If I want to think a little bit more into like the hexagonal architecture, or I don't know, clean architecture aspects, then I might have a use case which is like register customer, right? And then that register customer itself could be an interface. Correct me, maybe I'm wrong, just I'm thinking out loud.
No, please.
That register customer itself could be an interface that is serving a purpose, right? That is registering the customer. Could it also like inherit from the I find by ID, I find customer by ID, and I save customer interfaces, like to extend on the behavior that interface exposing, and then I inject that specific interface to my application layer?
Yeah. So where I first started doing this was in the iOS world, right? Because what I learned is that I may have the way iOS kind of structures certain things are coupled together that don't actually model real world in my mind. So case in point, geolocation data, right? So I may have a concrete underneath the hood CL core location manager, which gives me access to everything, but I don't want the subsystem to know about the implementation details, right? That low level specification. I don't want it to know about that. Yeah. I want it to know that it can go get geo coordinates when it needs it. It shouldn't need to care about the concretion of where it gets them. And that concretion can extend the geofencing and the geolocation and the user and the permissions and everything that cohesive bit cares about. It can implement all those things, but it can have separate interfaces so that various aspects of the subsystem that need to do highly specialized tasks can do those tasks without being leaked information they don't care about, right? And how does this play into the concept of the AI world, right? Well, okay, we know that we now have to give AI a bunch of context, right? So we don't want to give AI context about things we don't want it to think about, right? Because we're bloating the context we're using. So why would we do that with our software? Why would I give the reporting system access to save data when the reporting system should only ever be reading data? Now, there are multiple ways to go about this, right? You could do high availability read groups. You could use a CQRS pattern. You could use a mediator pattern. You could do this in your connection string jazz. I'm just pointing out a way that you can achieve this through interface segregation and solid principles. So it's always the same problems we're trying to solve, right? It's a question of where do we visualize the seam, the boundary, and how do we want to solve it based upon the requirements we have in front of us.
Yeah.
Can I answer your question?
Yeah, sure.
Awesome.
Thanks.
Yeah, no problem. So, and then we have like these third-party seams and get kind of to the potatoes, and this is kind of the wrap up, right? So we're gonna go through this, but the ISP bit and how I kind of came about to this was when default interface implementations became a thing. I was and still am using a C# build technology called Nuke, and this is how I actually structured the entirety of my build system. I microtized my offering because the way I have builds in C#, so this library I share with another developer, a friend of mine who is a very smart individual, and he does primarily web and I do primarily mobile, but we both use .NET to build. So we structured this entire offering on top of extending a third-party library. We built this entire structure on top of it so that I could have access to the same things that he had access to in my Xamarin builds, but not care about any of the web concerns. I don't care about Playwright or any of those things when I'm building a mobile application. So why should my build system give me access to those things? So this is how this concept started to become real to me. And the benefits and the downfalls, right? So let's talk about this, and then we'll talk about why the pattern, and then we'll talk about, again, we're going to dig into this build system example. And I know we're close to time, so I'm gonna push through and wrap it up kind of quick. But the benefits and the downfalls, right? There's trade-offs to everything, and this is one of the big things. I'm not one to tell you. Only Siths speak in absolutes, right? So there's no definitive thing that this is the way you must always do it. No. We have guidelines, we have rules, we have principles for a reason. They're not ironclad laws, they're principles. So, the traditional approach, right? It's simple. There's low initial overhead, but it violates a very real solid principle. It creates very rigid coupling. And again, we don't want coupling, we want cohesion. And we end up with a lot of God objects. We end up with a lot of objects that have 5,000 lines of code in them and 30 dependencies injected and all of these problems that come with not really understanding a small composable chunk of a subsystem, right? But the composition approach has pros and cons as well, right? So it gives you very focused roles, right? You get high reuse out of your microtized approach, right? You get very, very good test isolation, but you end up with a lot more types. Discoverability becomes a problem because now you have to think about, now you have to, when you're writing the code, you got to think, what do I have? What do I need, right? What do I need to solve the problem that I'm looking at? There's that discovery cost, which I think, while it's there, it's a very real thing. I think some of the modern tooling mitigates that. And then you have those default interface limitations, which, again, no state. So you have to be very careful about how you share state. Again, the abstract classes are better at sharing state. You have to be very careful about how you share that state around your subsystems using these interface composition techniques. So why did I get into this pattern? Again, the build system example, which is very real. We had very granular things that we wanted to do, right? Some builds I have artifacts, some builds I don't. Some builds have code coverage, some builds don't, right? Like I didn't want to prescribe and say all my things must do things the same way, because then how can I consume that? Now, if I go use this at a client as an example, and they don't have these concerns, now I'm bleeding my bad decisions into my client's process and potentially causing them duress because they may start to depend on something they don't need. And now I'm just spiraling this maintenance burden out of control. And then the dependency hell, right? Again, I'm still using the same concretion under the hood. I'm just ensuring that I don't couple various pieces of subsystems together that don't need it. Again, that's Stefan's comment earlier was very, very pointed, that we don't want to use interfaces to cause ourselves duress. We want to use interfaces to lead us to success. That's a very, very key distinction. But again, like I said, the build system example is where this really drove home to me. And this is going to be a practical walkthrough. And again, this became a thing because I needed to use various components across boundaries. A .NET build is a .NET build, but when we get into publishing a Docker image or a Razor page site or a SPA application or an application an Angular application, right? Like a Maui application versus a Xamarin application, all of those things have different components, different behaviors, and different concerns. They do different things. You try calling .NET Publish on an iOS application without a code signing key and see how far you get to production. But you can do that with a website all day long, and no one's gonna care. So understanding the needs of your system are important, right? And it allowed me to start stacking dependencies like Lego blocks, right? A nuke build is my starting point, and then I have certain things, and then things can do certain things. So I have a solution, and in order to restore a .NET application, I need a solution. So my can restore should have a solution, right? Like this is how we start to look at the compositional elements of our subsystem. They are no longer just interfaces that we use for testability or maintenance or all the other lies that we've told. They are interfaces that define the characteristics of the capabilities of our subsystems, the state that it manages, the state that it doesn't manage, the reducers that it has on that state. Like we now have a very real and very concrete understanding defined in our application around what things have, what they own, and what they can do with that ownership. Right.
I think so. On top of that, you could even like create I am iOS builder, and it could have or can a couple of those things. And then you just have the I am iOS builder in your pipeline, and then you have every tool that you need to do that, right?
So so it's fun. I'm laughing because that's exactly what I did, Shahab, right? Because you get even inside the Xamarin Maui world, .NET Build and .NET Publish do not act the same against iOS and Android. So some clients I have only do iOS. Some do iOS and Android. Why would I couple my iOS only clients and give them knowledge of stuff that I built that they don't even need?
Yeah.
So that's exactly it. I say iOS has code signing keys and code signing certificates and Apple developer stuff, but Android doesn't care about that. So I can segregate those interfaces and create a nuke build that is purpose built for the requirements of what it is that I'm trying to solve. And again, I'm harping on those requirements because even internal to my teams, any developer that works with me will tell you that if you ask me a question, the first question I'm going to ask you is, what's the requirement? Hey, Rodney, how do I do this? Or, hey, Rodney, I have this problem. Okay, what's the requirement? Because I'm not in the business of writing code for fun. I'm not giving away solutions to problems that you don't have. I only want to solve the problems that my clients have, not the problems they don't have.
Yeah.
So we can put properties, right? And this is where it started, right? Like I literally was like, I have a solution. I have a Git repository. I have a Azure DevOps repository, right? Like I have different things. And based upon what I have, defines the capabilities of what I can do. Right? So then I have different behaviors, right? Again, I can restore with .NET Core, means I have to have a solution, and I have to be able to do things, right? So I have that. So we explicitly did marker interfaces, and I know that a lot of people will tell you don't do marker interfaces. And I even told you earlier, like interface all the things is not great. We did this because I made the decision that I wanted a single point where everything understands its hierarchy. There are things that can do things and things that have things. Things can't do things, but things that have to have. And I wanted to describe that very clearly in the system. So that's why we went this approach. But now what you see here is a default interface implementation that forces a very specific way for me to do my .NET restores. Now, this is a very simple example, but you understand right here, right? Like when we get into testing, if I want to override testing and I have different testing concerns, we can do those things. If I'm using .cover versus coverlet, I can define those things based upon what I have and what I can do. And now I'm composing behaviors from default implementations and now I'm sharing behaviors at the interface layer without having to get into I've got to create this God abstract class and deal with all of this inheritance magic. No longer do I have to deal with all of the inheritance magic. I can create composable bits just from the interface definitions. And that to me was when I had the light bulb moment, and the default interface implementations was like, oh, and I was like, oh, this is how I should be describing my systems. I should be describing my systems based upon the capabilities, the ownerships, and the behaviors that they exhibit. Right? And then I can start to chain together these dependencies, right? So now, just like like I know, .NET Build, the CLI tool, depends on .NET Restore. It extends, for lack of a better term, .NET Restore. How do we know that? Because it will, by default, do a restore for you if you tell it not to. So it doesn't assume that you've done the restore, it will do it. So what does that mean? That means that .NET Build is a .NET Restore by definition, right? It has everything that it needs and the capability to do the .NET Restore. So it is a .NET Restore. It's not just a .NET Build. It's a .NET Build and a .NET Restore. And now I can describe that reality in my build system using these default interface implementations and share that behavior across all of my nuke builds. And this is where it was just like, oh, I just started to have way too much fun, right? So then we get into these cross-cutting concerns, right? Like I have Git version, right? You can use Git version, you can use NerdBank Git version, and you can use any manner of way to define your repository's versioning concept, right? It now gives us the ability to define these cross-cutting concerns and then reuse them across boundaries, right? So that cohesion concept comes back to play here again, right? We can have explicit overrides. So the creator of Nuke saw what we did with this particular library and gave us an explicit extension point to further our ability to go down this road. Right. So now we have an explicit override that he gives us the ability to say, oh, I want to inherit from this thing, and we can override the default behavior, which was invaluable. Right. And then this is the entire like comprehensive composition concept. Right. I have a pipeline, and my pipeline is a nuke build. It can restore. It can build with .NET Core. It can test. Notice it does not have the ability to publish. So I can define my own publish. Or at this point, we can accept that this pipeline is just a build-only pipeline because we have explicitly defined the behaviors that it has, and it does not have the ability to publish. Right? So now you're getting a way to see that you can look at a entity in your system, see what it extends, see what it is, and see what its purpose is just by the interfaces that it inherits. Right? And then there's this concept of like, now I can create these nuke targets, right? So I can update a solution, means that, again, I have to have a solution to update. And I can create this very specific targeted generation of solution items. But then if I have a client where I need to do this, but I need to do it slightly differently, I can just override it later, right? But I am now defining the again, we said earlier, the things that are going to change together live together, right? Like I'm now defining a coupled approach, but I can't update a solution if I don't have one to update, right? So why would I segregate those so thinly that now it's anemic, right? Now I'm not actually getting value because everything is way too scattered, right? So again, we have these composable parameters that we have, right? So like now I'm giving behavior to parameters because it's defined as a get only property. I can define the behavior and I can say that this is what it looks like to get to the artifacts directory across all of my builds, right? And now when I go to my build, I don't have to define that or redefine it unless I absolutely need to, right? It allows us to compose these behaviors in a very, very real way. Because now, again, like I say, I have a Git version, or I have Git version and I have a solution. So now I have a build version, right? Because the Git version plus the solution gives me a build version, right? Like you can start to look at these things as small composable Lego blocks that you can stick together and be that master builder and produce something that your requirements dictates, not just the only thing you know how to build, right? And leaking all sorts of information all over the place. So with that, we have kind of talked through the entire compositional approach in the modern C# world, using interfaces as a way to share behaviors, which is something we couldn't do before, and using interfaces to define and describe various portions of your subsystem so that high-level modules aren't coupled to low-level things, and they can take dependencies on just what they need in order to do their job, right? So these lessons learned, this is kind of where we kind of wrap everything up, right? We abstract with purpose, right? We do not just create interfaces for everything. We are defining, we are describing a living, breathing code base. We have to give it life, and we don't want to give it a bad life where we burden it with things it doesn't need. We want to give it just what it needs to be successful, right? So that it can grow and mature the way it's supposed to. We want to use composition over inheritance. We don't want 10 levels of depth to inheritance. Instead, we want to create composable pieces so that we can reuse them in the inheritance hierarchy effectively, right? We don't need to anymore put all these things in an abstract class to share behaviors. Now we can use the composition of interfaces and interface segregation to define real behaviors to share throughout our subsystem, right? We keep our abstractions granular, right? Because again, this is about cohesion. We don't want to leak all of this information all over the place. This becomes more realistic when you're doing like publicly facing things, but it's real inside your application, right? Even if your company doesn't, share third-party API surface with other things, this is still very real inside your own application. And I think that's probably the biggest takeaway for me. I didn't realize that defining my application as one organism, Rodney Littles, am one organism, but I'm a whole bunch of little organisms, right? I got cells and mitochondria and all sorts of other things. So to deny those things their reality, their purpose, kind of denies Rodney who he is, right? So we should describe our subsystem in very composed ways, right? Again, Little's substitution principle, right? We don't want to break contracts. We want to we want the thing that we inject to give just enough information and to be reusable through any polymorphic chain, right? So again, that V1, V2, as long as we have name, we know we have name, and we expect that contract to exist. But when we have a breaking change, okay, we expect a breaking change, and that's okay. And then we now can leverage modern C# default interface implementations, extension methods, and using the concept of defining the thing that we're concerned about and the things that it shares, rather than a microtized interface or a God interface that covers everything or is anemic and doesn't cover enough. And these are kind of the things that I'm trying to bring home to you that are actually valuable when it comes to writing real software in this world. Because all of these things were buzzwords when they came to my ears. I didn't understand them. And through my journeys, through making mistakes, through trial and error, I realized that I can use solid Gang of Four to produce real working maintainable software at scale. And I say that, I was making the joke with Shab, one of my clients currently has over 1.2 million lines of C# in a single code base, in a single application. So these aren't things that I tell you from oh, I read this in a book and it sounds like the right thing because that other smart person said it. No. I made the mistakes. I went out there and learned these. I went and told me it was the way to do it, and then they didn't concepts the right way. The right way to do it is dependent on we're trying back to the fundamental software engineering state. That's the way we do things, not because the senior said so, not because the architect says that this is how we do things. We only do it to solve problems, and the only problems we should be solving are the requirements in front of us.
Absolutely.
That's kind of the wrap up. Are there any questions, any thoughts, any comments, concerns?
I don't see anything in the chat. If someone has like questions, feel free to add it to the chat. And you could also like so like for me, like the gist of the talk is like look at your context, look what problems you want to solve, and create the solution that covers that thing. And
Yes.
another thing for me is like all of this goes about like being explicit about knowing what we are doing there. Like do not hide behind the implicitly interpreting things and giving like the implicit access to things that people shouldn't have. As always, I really enjoyed the talk. I see some looking into C# V next. What do you think about unions? Oh, I knew this will come up.
Oh man.
And in particular, close hierarchies. Do you see some potential abstraction pitfalls in them already, or do we need to try them out first?
So I'll jump to the last question. We always need to try it out first. I will never be the. I personally, I know some people that are that good. They can look at the thing and they can see it and they can see all the pitfalls and all the good and all the bad. I can't. I've got to go roll up my sleeves and play around in the dirt before I realize, oh wait, this dirt is red or this dirt is brown. I'm not that good. What about unions? So unions, discriminated unions, I didn't know what they were, but it's a functional concept that allows us to basically, it's kind of that either or, that railroad programming concept. So for me, I think it's going to be a problem for abstractions. As a matter of fact, I was just looking at the implementation because I think it's coming in C# 14. I think we're getting our first look at it. And I was looking at it the other day and I was digging through it and I was like, ooh, this is going to get weird when you have a thing that's V1 and V2. But I think what it's going to, the pitfalls are going to be and where we're going to run into problems is, to Shahab's point, when we are not explicit in what we're doing, when we're just kind of doing it and don't know why we're doing it, explicit with as many problems, that it's possible. But I personally am going to be actually looking at unions and refocusing my understanding of this exact talk based upon what value that new C# language feature comes in and brings. And that's what Shahab and I were talking about, right? These are all new language features they're bringing in. They're telling us, hey, you asked for it, we're giving it to you. But they don't describe how we should use it. They don't tell us, what the pitfalls are. So that's where we have to try it out ourselves, and we should not try it out in our client's code. We shouldn't come in to work the day after C# 14 hits and say, oh, we got discriminated unions, let's go break the world. No. What we should do is we should write a little sample application, to do something a little bit more complex than to do, but not much more complex than to do. And we should iterate over these things, bring them into our sandboxes, play with them, see what, because again, all sand in sandboxes is not created equal. Some sand is coarse, some sand is fine grained, some sand is white, some sand is golden, some sand is brown, some sand is wet. If you don't understand all of what that could do to your system, you are creating the maintenance burden. You are creating the liability. So you have to understand, yes, the C# language team is giving us the things that we want, but they're also giving us a foot gun that we need to be very, very careful with.
We talked, I think, before the session, about this. To me, a lot of features that we are getting from for the new C# versions is some like the feedbacks the community provided for the C# team, that we need this feature for whatever reason that we thought we need that.
Right.
And then the C# team delivers and tells us about this is how it is, how it works now. But again, I think the burden is on the community back then. Okay, you asked for the feature, you have the feature, now describe how to use the feature, right? And bring the best practices and the patterns. So I think this is like a two-way road to my, because I don't see like the C# team comes and tells us like how to do that in your DDD concepts, right? Because then it's DDD community's responsibility, whether you use F# or C# or any other language, to leverage those features of that language in your context.
Yeah, I think it's explicitly our job as the community to do that, because we asked for it. And again, Microsoft, back to the requirements, Microsoft isn't just adding this stuff because they feel like it's a good idea. We are asking for it. So we should hold them accountable to whether or not they got the implementation right. Did they satisfy the requirements that the community gave them? We are responsible for holding Microsoft accountable for that. And if it doesn't meet the mold, or it's not, again, like I said, I showed you some pitfalls that I learned about default interface implementations along the way. It's okay. It's not going to be perfect day one, but if we don't use it, we don't kick the tires on it, we don't exercise the code, Microsoft won't get the feedback, and they'll just keep giving us features that don't actually advance the language.
Sorry, Rodney, we kind of need like to take care of like the have a timeout.
Yeah, no problem. I know we're over time. Let's wrap
it was a great session, like to go back to the basics and like this talk about all of these things that are also important, like as being like in the modern technologies, and use them. And thanks from Stefan. Yeah, there's no more questions. I would like to say have a good day, have a good evening, have a good night, wherever you are in this blue planet, I would like to refer to it. And thanks, Rodney, for joining us as well. Last like comments or anything with the community, go for it.
Go forth and build software, learn, grow, become better. That's it. That's the key.
Perfect. Thank you, everyone. Goodbye.